in section 5.7, we will be describing number patterns. So this is the last section of chapter 5, and your goals for this section is to use inductive reasoning to describe pattern. And second goal is to write rules for arithmetic sequences. So inductive reasoning is a reasoning that what you do is make an observation and see what's going on, look for any kind of pattern, and you make a conclusion. So the conclusion that you make from making an observation is called a conjecture. So conjecture is another word for conclusion made using inductive reasoning. Another term that you need to know today is called a sequence. So since we're using the inductive reasoning to describe pattern, sequence is what's called a number pattern. So we have sequence of numbers that has a pattern to it. And each number in the sequence is called a term. So if there's a first term, second term, third term in the sequence, each of those numbers has a particular term number. And any sequence that is formed by adding or subtracting is called the arithmetic sequence. So you need to know what that term means, arithmetic sequence. So because we're finding something that's being added or subtracted as a pattern, we are going to be able to write a arithmetic sequence function rule. And then the last word that you need to know is called a common difference. And if you notice, it's exactly what it is. It's a difference where the all the differences in common, so it's called a common difference. So in this pattern, in the sequence 2, 4, 6, 8, since they all go up by 2, the common difference is 2. We are also going to be writing a arithmetic sequence. So arithmetic sequence rule is given by a of n is equal to a plus n minus 1 times d. So from a sequence like 2, 4, 6, 8, you should be able to write a function rule that looks like this that fits that pattern. So in this equation, this right here is called the nth term. So if I'm looking for the fifth term, I will put n equals 5, and I would call this to be the fifth term is equal to, and A stands for your first term of the pattern. So in the sequence of 2, 4, 6, 8, 2 would be my first pattern. First term. And the n is your term number. So if I want you to find the 10th term, n would equal 10. And the d, this right here, is your common difference. So that number will tell you what the pattern is. So if it goes up by 4, d would equal 4. If it goes down by 2, d would equal negative 2. So if I had a sequence 27, 21, 15, 9, and dot, 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 I could write a function rule, the arithmetic sequence rule, for this sequence. So if you notice, my first term, which is A, is 27 because this is my first term. And the common difference, that means what was the pattern to create this, from 27 to 21, it went down by 6, and 21 to 15, it went also down by 6. So my common difference, D, is negative 6. So if I know my A, my first term, and the common difference, I could write this function rule. So the function rule for this sequence would be A sub n, A of n, which is equal to the first term, which is 27, plus, and you keep n minus 1, times the common difference. And this equation will give you any term number in that sequence. So if I want to know what is the 99th term of this sequence, I would set n equals 99 and plug it in for n. So I would say the 99th term is, so this means 99th term is 27 plus 99 minus 1 times negative 6. So 27 plus 99 minus 1 is 98, and 98 times negative 6 is negative 588. And 27 plus negative 588 will give me negative 561. So the 99th term is negative 561 in this sequence. And that's what you need to do today. So if I'm asking you to find the first term, you set n equals 1. If I said the fourth term, you set n equals 4. And if I said the ninth term, n would equal 9. And you plug each one of those numbers in. And that's how you write arithmetic sequence and find each term numbers as needed.